Okay, 160 microcoulomb charge with a mass of 0.23 kilograms is approaching another one. So this guy's fixed. Can't move, right? This one's flying in here flying directly at it, right? Okay. When it's 2 meters away, it's going 34 meters per second. Presumably, it's going to stop before it reaches this thing, right? And so it's going to stop at some distance x, where its velocity will be 0. That's the implicit thing there, right? So in this situation here, what we've got is kinetic energy and potential energy at this point. Here it's going to have only potential energy, okay? So I'm going to say that in this situation right here, I'll call this to be 4, right? It's going to be K times Q1 times Q2 over R1, which is 2 meters, right? And then it also has kinetic energy, so plus 1/2 mv squared, right? I'll call that V2 just for kicks, or V1, sorry. Okay, and then that equals K Q1 Q2 over R2, which is really, this is R2, okay? Plus 0 because it has no kinetic energy, okay? Okay, so let's plug all those numbers in here. This is our first step, recognizing that it's kinetic plus potential turns into just potential. So let's plug in numbers here. So K, so 8.99 times 10 to the 9th, right, times 160 e minus 6 times 160 e minus 6 divided by, and it's 2 meters away to begin with, right, plus 1/2 0.230 times 34 squared equals, this is our second step here, just the potential. So K, 160 e minus 6, 160 e minus 6 divided by, we just don't know this R2, right? Okay, I think we can do this. So let's do the next step here, okay? Actually, I'll do the next step here. So this term right here turns out to be let's see, there it is. That is 115.072. Okay, so we'll do, that's 115.072. This term here ends up being, let's figure that out. What is that? 0.5 times 0.23, that is 132.94. Right? And then that is equal to our K times 160 e minus 6, right? Times 160 e minus 6 over R, right? And now we just have to solve for R. That's the distance, right? Okay, so I'm going to add those two. And I'll end up with R is equal to K times 160 e minus 6 times 160 minus 6 over 115.072 plus 132.94. So let's figure that out. I'm going to do alpha F1. So K, alpha K, I stored that value 8.99 times 10 to the 9th in there, times 160 e minus 6 times 160 e minus 6 divided by 115.072 plus 32.94. That's the one limitation. If you're in fractions, you can't use the up arrow to put the values in. Let's see. And I'm getting that R is 0.927955. So R, it gets as close as 0.928 meters. Okay. Which is interesting to me because when it's 1 meter away, it's going 12.5, right? But it stops in the next 3 centimeters, right? Or sorry, next 7 centimeters, right? It stops, basically, right? So that tells me that it's decelerating at a faster and faster rate, which is true. Okay, we really can't SUVOT this. We have to use our energy because it's it's nonlinear. The acceleration gets more and more as it approaches because the force gets more and more. And our SUVOT only works if the acceleration doesn't change. We have to use calculus. All right.